Everyone, I am Priti from BSc Final Year Physics Honors. My class roll number is 13 and my topic is types of polarization. First of all, before discussing about types of polarization, we discuss about the polarization. The polarization is actually the alignment of the dipole moments of the fixed or induced dipole in the direction of the applied electric field. यानी कि जब हम किसी डाइलेक्ट्रिक मटेरियल को इलेक्ट्रिक फील्ड में पुट करते हैं, इलेक्ट्रिक फील्ड हमारा E है, देन द मूवमेंट ऑफ द पॉजिटिव एंड नेगेटिव चार्जेस विल टेक्स प्लेस. द पॉजिटिव चार्ज मूव इन द डायरेक्शन ऑफ द अप्लाइड फील्ड एंड नेगेटिव चार्ज इन द अपोजिट डायरेक्शन एज शोन इन दिस. द मूवमेंट ऑफ दीज पॉजिटिव एंड नेगेटिव चार्जेस ऑफ द एलिमेंट responsible for creation of the electric dipole moment in the atom. Then we discuss about the types of polarization: electronic polarization, ionic polarization, orientational polarization, and space charge polarization. Then we say SI unit of the polarization is coulomb per meter square. First of all, electronic polarization. Electronic polarization is shown in this figure. When an atom is placed in the electric field, then it is polarized. The electronic polarization is mainly explained with the help of rare gases. The rare gases are separated with a large distance and the interaction between this is taken as very small. It can be neglected. When atom without any external field, then this is the positive center charge plus Ze, and this is our electronic cloud. In the electronic cloud, the negative charge is uniformly distributed. The center of the negative charge also present here, minus Ze, without any field. When the electric field is applied, then this is our original position without any displacement, and when electric field is applied, this is without field, and when electric field is applied on this, then the movement of the electron cloud will take place. This is our positive charge center and this is our negative charge center. The displacement of the negative charge center from the positive charge center will takes place by a distance of x. This is our positive charge center, original nucleus, as in this. This is our positive charge center and this is the negative charge center. The negative charge center is displaced by a small distance x. Then we say that here the nucleus of the charge Ze is surrounded by the electronic cloud of charge minus Ze distributed in a sphere of radius r. Thus, the charge density rho is given as rho is equals to charge per unit volume. Charge is minus Ze. It is divided by 4 by 3 pi r cube. It is equals to minus 3 by 4 into Ze divided by pi r cube. Say this equation first. When this system is subjected to an external field of intensity E, then electrons and nucleus experiences a force, Lorentz force, of magnitude Ze into E. F is equals to Q into E, and Q is our charge Ze and E is the external applied field. The forces on the nucleus and electrons is in the opposite direction. Therefore, the nucleus and electronic cloud are pulled apart. They are pulled apart and the new Coulomb force is developed between them, which tends to counter at the displacement. जब ये दो पॉजिटिव और नेगेटिव चार्ज विद ए स्मॉल डिस्टेंस ऐसे डिस्प्लेस हो जाएंगे, इनके बीच में x डिस्टेंस होगा, तो इसके ऊपर कूलॉम फोर्स लगेगा. मान लिया ये डिस्टेंस जो हमारा स्मॉल डिस्प्लेसमेंट हुआ है उसको हम x बोल दें. टू कैलकुलेट द इंड्यूस्ड डाइपोल मूवमेंट इन द एटॉमिक मॉडल, इट इज़ फर्स्टली अज्यूम दैट इलेक्ट्रॉन क्लाउड्स जो हमारी हैं वो एक्सटर्नल फील्ड के द्वारा डिस्प्लेस की गई हैं. थस द लोरेंज फोर्स इज गिवन एज माइनस Ze into E. and Coulomb force is ZE into charge enclosed by the sphere of radius x divided by 4 pi epsilon naught x square. The small sphere as shown in this figure, this is of x radius. Then Coulomb force is k q1 q2 divided by r square. Value of k is equals to 1 upon 4 pi epsilon naught, and q1 q2 and r square is the distance between the two charges is x square. The charge enclosed is in the x radius circle is given by q is equals to 4 by 3 pi x cube into rho, because rho is equals to q by v and q is equals to rho into v. From first equation we put the value of rho 4 by 3 pi x cube and this value of rho. Then by solving this we get the value of the charge enclosed by a sphere of radius x is equals to minus ze into x cube divided by r cube. Hence the Coulomb force is equals to ze divided by 4 pi epsilon naught x square into value of the charge enclosed by sphere of radius x. Then we get the Coulomb force is equals to this value. In the equilibrium position, the two forces are equal, that is the Lorentz force and the Coulomb force are equal. By putting this we get the value of x is equals to 4 pi epsilon naught r cube e into e divided by ze. This is equation third. This displacement of the electron cloud जो है हमारा, इसका डिस्प्लेसमेंट x हुआ है वो डायरेक्टली प्रोपोर्शनल है हमारे एक्सटर्नल अप्लाइड फील्ड के ऊपर. Thus the two charges are now displaced by distance x under the field constitute an electric dipole, and has induced electric dipole moment is given by Pe is equals to Ze into x. P is equals to Q into 2L, and 2L is the distance between the two charges, which is taken as x in this case. Then by putting the value of x from the below equations, Pe is equals to Zex, and value of x is put in this equation, we get Pe is equals to 4 pi epsilon naught r cube e. Pe is directly proportional to e. We get Pe is equals to alpha e into e. This is equation 4, and from this and this we get the value of alpha e is equals to 4 pi epsilon naught r cube. This is equation 5th. Alpha e is the electronic polarizability. Thus induced electronic dipole moment is also proportional to the applied field E. Thus the dipole moment per unit volume is called electronic polarization. Pe is equals to n into Pe. ये हमारी टोटल पोलराइजेशन हो जाएगी, जिसमें n क्या है, हमारी नंबर डेंसिटी, नंबर ऑफ एटम्स पर यूनिट वॉल्यूम. देन Pe is equals to n alpha e into E, but we have also Pe is equals to this value. From this equation and this equation we get this equation by equating these two equations. Epsilon r minus 1 is equals to n alpha e divided by epsilon naught. This is equation 6, where epsilon naught is our dielectric constant. First of all, these assumptions are not accepted, but by taking their results they gives a more accurate results about their atomic parameters. Hence this is very useful. Second is atomic और ionic polarization. जब हम किसी भी आयनिक क्रिस्टल को इलेक्ट्रिक फील्ड में पुट करते हैं तो इनके केस में भी जो हमारे आयंस हैं उनमें डिस्प्लेसमेंट अगर हो जाती है. नॉर्मली जब हम विदाउट फील्ड किसी भी क्रिस्टल को देखते हैं तो उनकी चार्जेस की जो पोजीशन होती है वो ऐसी होती है, मान लिया कि माइनस प्लस माइनस. जब हम फील्ड अप्लाई कर देंगे तो हमारा इसके अंदर क्या होगा, जो हमारा नेगेटिव चार्ज है वो तो टुवर्ड्स द फील्ड डिस्प्लेस हो जाएगा, और जो पॉजिटिव चार्ज है वो इन द अपोजिट डायरेक्शन ऑफ द फील्ड डिस्प्लेस हो जाएगा. इन द प्रेजेंस ऑफ आवर एक्सटर्नल फील्ड the charges are displaced in this way. This is our ionic polarization. Then we say that this type of polarization जो हमारा ionic polarization है only occur in the ionic molecules such as NaCl, KBr, KCl etc. कंसिडर द अरेंजमेंट ऑफ द आयनिक मोलिक्यूल्स एज शोन इन द लास्ट फिगर, जो हमने पीछे देखा था। जब हम इलेक्ट्रिक फील्ड के एब्सेंस में देखेंगे तो नॉर्मली सेट होंगे, जब हम इलेक्ट्रिक फील्ड अप्लाई कर देंगे तो उनके अंदर डिस्प्लेसमेंट प्रोड्यूस हो जाएगी। एंड ड्यू टू द डिस्प्लेसमेंट ऑफ द आयन, the induced dipole moment Pi is introduced and is proportional to the applied electric field and ionic polarizability alpha I. Then Pi is written as alpha I into E. Say this equation 7. This induced dipole moment in turn produces an induced polarization. The polarization produced for a crystal having n number density, then total polarization is written as Pi is equals to n alpha I into E. हम क्या कहते हैं कि जो मोस्ट ऑफ द मटेरियल्स होते हैं हमारे पास, उनमें जो आयनिक पोलराइजेबिलिटी है वो हमेशा लेस होती है इलेक्ट्रॉनिक पोलराइजेबिलिटी के। अप्रोक्सीमेटली जो आयनिक पोलराइजेबिलिटी है वो इक्वल होती है 0.1 इंटू अल्फा ई मीन्स इलेक्ट्रॉनिक polarizability. Our third is polarization is dipolar और orientational polarization. Dipolar और जो polarization है वो हमारा only and only polar molecules के अंदर अप्लाई होता है। पोलर मोलिक्यूल्स कौन से होंगे? जिनके अंदर हमारा जो पॉजिटिव चार्ज है न्यूक्लियस है और जो नेगेटिव चार्ज सेंटर्स है वे एक दूसरे से कुछ डिस्टेंस के साथ सेपरेट होंगे। मान लिया ये पॉजिटिव चार्ज हो गया एंड ये नेगेटिव, ये किसी न किसी डिस्टेंस से सेपरेट होंगी। इनके एग्जांपल होंगे H2O, HCl, नाइट्रोबेंजीन एट्सेट्रा। जब हम नॉर्मली विदाउट एन एक्सटर्नल फील्ड देखते हैं तो हमारी डाइपोल्स की डायरेक्शन जो है वो रैंडमली ओरिएंटेड होती है, जैसे कि इस फिगर में दिखाया गया है। बट व्हेन वी अप्लाई एन एक्सटर्नल फील्ड इन द पैरेलल टू दिस material, then all the dipoles are produced in the direction of the field. Then we see that the alignment of the dipoles is opposed by the thermal agitation, which tends to randomize the dipoles. Because of this reason, the calculation of the dipolar polarization is done under the thermal equilibrium condition. Assume that the dipole सिस्टम प्लेस्ड इन ए यूनिफॉर्म फील्ड। मान लिया कि हमने जो हमारे पास ये डाइपोल है माइनस क्यू प्लस क्यू, ये हमने किसी भी यूनिफॉर्म फील्ड ई के अंदर पुट कर दिया तो क्या होगा? इसके अंदर जो ये प्लस क्यू चार्ज है इसके ऊपर इस डायरेक्शन में फोर्स लगेगा अलोंग द फील्ड एफ, जिसका मैग्नीट्यूड होगा क्यू इंटू ई। ऑल्सो माइनस क्यू चार्ज एक्सपीरियंसेस ए फोर्स इन द अपोजिट डायरेक्शन। द डायरेक्शन ऑफ दीज फोर्सेज is opposite to each other. Due to this, a torque exists in this dipole, which is written as in this form: q tau is equals to p into e, and the magnitude of this torque is equals to pe sin theta, and theta is the angle between this dipole p moment p, dipole moment p, and electric field E, theta angle between them. Then the torque is responsible for the alignment of this dipole in the direction of the applied electric field. Then the potential energy of the dipole is written as U is equals to minus P dot E, which is equals to minus PE cos theta. When theta is equals to 0 means the dipole is parallel to the applied field, then the energy of the dipole is minimum. But when theta is equals to 180, the energy of the dipole is maximum, means that the dipole is anti-parallel to the applied field. Then we say that all the dipoles are not possible in the minimum energy state, means all the dipoles not present parallel to the applied field. Then by solving this condition, we say the component of the dipole in the direction of the applied field, मान लिया कि जो हमने फील्ड अप्लाई किया वो एक्स डायरेक्शन में अप्लाई किया, तो किसी भी डाइपोल का कंपोनेंट अगर हम फील्ड की डायरेक्शन में लेंगे, मींस अगर हम इसका फील्ड की डायरेक्शन में कंपोनेंट लेंगे तो वो पी कोस थीटा होगा। तो इसे हम क्या लिखेंगे? पी ऑफ एक्स इज इक्वल्स टू पी कोस थीटा। Then according to Boltzmann statistics, the probability of finding the dipole within the solid angle theta and d theta is proportional to the Boltzmann factor f theta, which is equals to exponential of minus u divided by kbt is equals to minus exponential of potential energy की हम वैल्यू पुट कर देंगे b cos theta divided by kbt. This is equation written as first. Therefore, the average value of the moment contribution per dipole PD is written in the form of this. Then in this equation, value of px is equals to p cos theta and value of this is equals to this, and the f theta is given by the equation first. Substituting all these values, we get the value this. So now substituting a is equals to pe divided by kbt and t is equals to cos theta and dt is equals to minus sin theta d theta. Equation third becomes, and also by changing the limits we can change limits as t is equals to cos theta. When theta is equals to 0, then t is equals to 1 and theta is equals to 180 means pi, then t is equals to minus 1. Also changing the limits and putting the values, we get the expression this. Then it is as p into integral minus 1 to 1 f dash a divided by integral of this and f of a. By using this formula, we write this as log of f of a, means p d divided by a log of minus 1 to plus 1 exponential of a t into dt. Then solving this, we get the equation p into la. L of a is also written as cos of h hyperbolic a minus 1 by a. Then L of a is a function which is known as Langevins function. Debye apply this relation to an electric dipole gas. Then plot the graph between the Langevins function L of a as a function of x. We see the graph as shown in the figure. When the value of a is very large, it is large when value of e is very large or the value of t is very small, then we say that the function L of a approaches to saturation value at unity. This becomes saturated at unity. This corresponds to the maximum alignment of the dipoles along the direction of the field. For a small value of a is less than 1 or p is less than kbt. We have cot hyperbolic a expansion is this. Then L of a is equals to approximately a by 3. This is equation 5th. Now substituting the value of L of a in equation 4 and replacing back the value of a, we get this equation. Then the dipole polarizability per dipole becomes alpha d is equals to pd divided by e, which is equals to this. It is clear from this equation the value of orientation orientational polarization is temperature dependent and it is inversely proportional to temperature. Then if we denote alpha naught as a sum of the electronic and ionic polarizability, then from the equation this we get the total polarizability may be written as alpha is equals to alpha naught plus p squared divided by 3 kbt. This is our Langevins-Debye equation. Then fourth is space charge polarization. The space charge polarization occur in the multi-phase dielectric materials. When a dielectric is placed in the external applied field, this diagram is without any field. This is normally written say in this form, and when an electric field is applied, then the charges plus and minus charges are coagulates on the electrodes. The positive charges coagulate in this surface and negative charges in this surface. This produces an dipole moment in the dielectric material, and our grain boundary is represented as this form. This is our space charge polarization. Also, the total polarization is written as the sum of the all these polarization: electronic polarization, ionic polarization, dipolar polarization, and by substituting these all values we get the total value of the polarization. Thank you.